So now that we got through the intro, we're going to go back and we're going to talk about graphing sine and cosine. So real-world applications as meteorology, the normal daily high temperature, 10 degrees Fahrenheit in Savannah, Georgia, can be approximated by t equals 76.4 plus 16 cosine. And then that expression, pi t over 6 minus 7 pi over 6, where t is time in months, t equals 1 corresponding to January. Find the normal temperature for July and November. So, if I'm looking at July, July is the 7th month. So that means I'm going to replace the t with 7. Well, 7 pi over 6 minus 7 pi over 6, of course, turns into 0. The cosine of 0 is 1. 16 times 1 is 16. 16 plus 76.4 would give me 92.4 degrees, which makes sense for Savannah, Georgia in July. Now, if we do November, November is the 11th month. So we'd make this 11, or we'd make that 11. That'd become 11 pi. 11 pi minus 7 pi is 4 pi. 4 pi over 6 would give me 2 pi over 3. When I'm done simplifying the inside part, so I go to my calculator, and I do 76.4 plus 16 cosine. Again, make sure you're in radians. All right, so we're gonna make the transformation to radians. 2 second pi divided by 3. And it's 68.4, which makes sense again for Georgia. Savannah, Georgia, drove through there last year going to Disney World. So basically that makes sense. It's about 68.4 degrees. All right? And temperature is going to do that. It's going to go up. It's going to go down. It's going to go back up. So basically it makes sense that it would be a periodic function. And the fact that it corresponds to a sine or cosine graph makes it even better. Okay? So we'll start with graphing sine. And to get an idea of why it is, we all know it's periodic. We went through it in the introduction. Here's why. If I plug in 0, the sine of 0 is 0. If I plug in pi over 6, I get 1/2. If I do pi over 4, I get root 2 over 2, which is approximately 0.7. If I do pi over 3, I would get root 3 over 2, remember? Which is about, 1.7 divided by 2 is about 0.85. And finally, I get the pi over 2, which is 1. Okay, now, when I graph it, here's 0, 0. I'm going to end up at 2 pi eventually, so I'll put that over here. That's going to be pi halfway. It's going to be pi over 2. Okay? So, if I look at pi over 2, it's 1. Now, here's where you got to be careful. All right? Pi over 4 is halfway there. And that's my 0.7, which is about there. Pi over 6 is going to be all the way over here at 0.5. But you notice it's not linear. So in other words, it doesn't form a straight line. So the curve kind of looks like that. Now, when you get back to pi, okay, when you get back to pi, you're back to 0. That's because 2 pi over 3 is 0.85. 3 pi over 4 is about 0.7. 5 pi over 6 is about 1/2. So they're symmetrical, kind of like a parabola, until we get back to pi, which is 0. Then 7 pi over 6, believe it or not, is negative 1/2. So about here, we're at negative 1/2. When we get to 3 pi over 2, which is halfway between them, the only difference is, remember, sine was negative, so instead of 1, it's at negative 1, and then it would come back to here. All right? Now, for those of you that didn't like the unit circle, all right, the good news is it's not really affecting the unit circle. If you know that shape, you can do the rest of them, okay? Now, with cosine, okay, we're just going to do some mile markers. So the cosine of 0 is 1. Pi over 4 is the root 2 over 2, which is the 0.7. Pi over 3 is the 1/2. Pi over 2 is 0. 2 pi over 3 is negative 1/2, so that's the difference. 3 pi over 4 is negative 0.7. 5 pi over 6 is negative root 3 over 2, which is about negative 0.85. So we'll throw the positive 0.85 there. Pi goes down to negative 1. 3 pi over 2 brings it back to 0. And then 2 pi brings me back to 1. So if I have the same interval, so there's pi, there's 2 pi. Difference number 1 is mentioned in the review. We're going to start at 1. So at 0, we're at 1. And at 2 pi, because it's periodic, we're also going to be at 1. At pi, the halfway point, you'll notice we're at negative 1. Okay, at pi over 2, and this is important, all right, and 3 pi over 2, that's when we're at our zeros. All right, so instead of the zeros being at the halfway points like they are in sine, it kind of looks like this. All right, so it kind of looks like that. Again, you don't have to know these values. I know some of you hate the unit circle with a passion, but that's the idea. Now, what are some of the things? So domain and range. So forgot that. Okay, domain is all the possible values of x. Domain is all the possible values of x. Well, for sine, we're going to have all real numbers. All right, the domain gets affected when we start doing tangent and cotangent. For range, for this one, you got to see where it tops out and bottoms out at. So in other words, it tops out at 1 and bottoms out at negative 1. All right, so the range is simply the inequality from negative 1, all right, to positive 1. In interval notation, it would look like that, negative 1, 1. So interval notation, remember we just use the endpoints as an ordered pair. Because it includes them, we use the brackets. If it didn't include them, it would be parentheses. All right. For cosine, again, nothing's excluding it, so all real numbers. And it, too, goes from 1 to negative 1. So it has the same range, negative 1 less than or equal to y, less than or equal to 1, or hopefully negative 1, 1. All right. So the domain and range, remember, the domain is all the possible x values. The range is where the y is. The domain for sine and cosine is going to be all real numbers. Now, one of the things we discussed that can change is what's called amplitude. The amplitude of y equals a sine x and y equals cosine x. A represents half the distance between the maximum and minimum values of the function as given by. Amplitude equals the absolute value of a. All right, so whatever number is directly in front of the whole thing, not in front of the variable, in front of the whole expression is your amplitude. So here's how it affects it. Here's what you do. Okay? When this is just x, okay, your domain, your period, all right, in other words, how long it takes to repeat itself is 2 pi. Okay? So, if I look at some graphs, basically this is what I would expect you to do, 2 pi. All right, and then double that, or whatever, later it won't be exactly double, but 2 pi and 4 pi. So I expect you to show 2 cycles. You're going to take the first cycle and divide it into fourths. All right, so halfway to 2 pi is pi. Halfway to pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. So I just expect you to take the original, all right, the original, and do that, and divide it into fourths. When there's a horizontal shift later in the week, we'll talk about what happens. Okay, so basically, every sine graph starts at 0, ends at 0 when there's nothing outside it, like we talked about the other day, and hits 0 in the middle. At the first quarter point, it reaches its maximum, and at the third quarter point, it hits its minimum. Well, the only difference is when we graphed them on the calculator or Desmos, and when we graphed the first one today, this was 1. Well, it's not going to be 1 anymore. All you're going to do is realize that this is 2. And instead of negative 1, this is negative 2. The easiest way to explain it is pi over 2. The sine of pi over 2 would be 1, and 1 times 2 is 2. So whatever the amplitude is, that becomes your max and min. And then I just connect them like this. This is what sine graphs, unless there's a negative, are going to look like. Okay? Now, for the other part, this is all I expect you to do. You don't have to write them out, but kind of estimate where those other points would be and finish up your graph. Okay, and finish up your graph. The domain is all real numbers. Now the range gets impacted because the range is no longer -1 to 1 because now it goes from what? -2 to 2. So the range goes from -2 to 2. And the amplitude is simply the number in front of it, too. It's never negative, as we'll see in a second. All right, so notice the graph is the same each time. Now, when things are negative, they flip. Okay, so in other words, normally a cosine looks like this. Starts at the max, goes to the min, comes back, kind of looks like that. Well, when you have a negative, it's going to flip. Well, the amplitude, though, is the 1/2. So what you basically think about is, okay, instead of 1 and -1, this is now 1/2 and -1/2. So if I plugged in 0, the cosine of 0 is 1. 1 times -1/2 is -1/2. So instead of starting at the top, because it's a negative, it's now going to start at the bottom. Same idea. First period ends at 2 pi. Second period ends at 4 pi. Halfway to 2 pi would be pi. Okay, and in between would be pi over 2 and 3 pi over 2. All right. So when I graph, this is what I would expect to see in the cosine. First off, it starts and ends at the same spot. At the halfway point, it's opposite the other spot. So in this case, since it's -1/2 at the halfway point, it would be at 1/2. And then at the quarter points, cosine is 0. All right. And then, like we said, we just repeat ourselves. So that's going to be there. Make sure it hits 0 at the quarter points. And there we go. The domain, like we said, is all real numbers. And because the amplitude is 1/2, the range is -1/2 to 1/2. So whenever you graph a sine or a cosine, all right, whenever you graph a sine or a cosine, sine's going to look like this each time. All right. Boom, boom, boom. You put the zeros at the starting point, the middle point, and the end point. The first quarter point, it's at its max. Third quarter point, it's at its minimum. Cosine. Okay, cosine. It's going to look like a U. All right. The difference is, if there's no negatives involved, max and max, 0, 0. And halfway it's at its minimum point. That's what it is each and every time. Now this one was a negative, so it flipped it. Okay, so now we're going to affect the period. All right, now we're going to affect, actually no, what we're going to do is we're going to skip that, and we'll do that in a separate video.